Dear students, today we will discuss about the projections. Now projection is basically one operation where we can convert a three-dimensional object description into a two-dimensional object description in the view plane. Now whenever the world coordinate description of an object in a scene are converted to a viewing coordinate system, we can project the three-dimensional object onto the two-dimensional viewing plane. Now if we consider the projection, basically there are two types of projection methods. First one is the parallel projection and second one is the perspective projection. Now in case of parallel projection, the coordinate positions are transformed to the viewing plane along the parallel lines as we are seeing in the figure. But for the perspective projection, the object positions are transformed to the view plane along lines that converge to a point which is basically called the projection reference point or the center of projection. So in case of perspective projection, the projectors are not parallel to each other. The projectors will converge into a point which is basically known as the center of projection or projection reference point. Now if we consider the parallel projection as the projectors, that is the connecting line of P1 and P1 dash as well as the P2 P2 dash, these two connecting lines are basically known as the projector. And in case of parallel projection, the size of the object remains same as it was in the original. But in case of perspective projection, this is shown in this figure, the projectors are not parallel to each other. That is, in this figure the line P1 and P1 dash and the connecting line P2 P2 dash are not parallel to each other. They intersect to a point, and the intersection point of these two lines is basically the center of projection, right? And in case of perspective projection, the size of the object in the view plane or in the projected plane is smaller than the actual object. That is, P1 dash P2 dash is smaller than P1 P2, and the plane at which we are taking the projection of the actual object is basically known as the view plane. So here it is the view plane where we are actually projecting the object. So a parallel projection preserves the relative proportion of objects, and this is the method that is used in drafting to produce scale drawings of three-dimensional objects. Accurate views of the various sides of an object are obtained with the parallel projections, but this does not give the realistic representation of the appearance of the three-dimensional object. So in case of parallel projection, we do not get the realistic representation of the object. But in case of perspective projection, which produces the realistic view of the object, but it does not preserve the relative proportion of the object. Projections of the distant objects are smaller than the projection of the object of the same size that are basically close to the projection plane. So as we are seeing in this figure, the same object is placed in a near and at a distant position with respect to the view plane, and the projected image of the actual object is smaller for the object which belongs to the far away from the projection plane, and the projected image of the object which is nearer to the view plane is larger than the first one. So the projection of distant objects are smaller and the projection of the nearest object is larger. And now if we consider the parallel projection, basically there are two types of parallel projection. One is the orthographic parallel projection and the other one is the oblique parallel projection. When the projection is perpendicular to the viewing plane, we have an orthographic parallel projection. Otherwise, we have an oblique parallel projection. That is, if the projector is perpendicular to the viewing plane, then it is known as the orthographic projection, and if the projection vector is not perpendicular to the projection plane, then it is basically known as the oblique projection. Now, orthographic projections are most often used to produce the front, side and top views of an object, as we are seeing in this figure. Front, side and rear orthographic projections of an object are called the elevations, and a top orthographic projection is called a plane view. Now, the engineering and architectural drawings commonly employ these type of orthographic projections because the length and the angles are accurately depicted and can be measured from this type of drawings. We can also form orthographic projections that display more than one face of an object. Such views are called axonometric projection. As we are seeing in the figure, axonometric orthographic projections are commonly used in projection, which is also basically known as the isometric projection. We generate an isometric projection by aligning the projection plane so that it intersects each coordinate axis, that is x axis, y axis and the z axis, in which the object is defined at the same distance from the origin. So in case of the isometric projection, the projection plane is placed at the equal distance from the origin. Here we are seeing an isometric projection of a cube. The isometric projection is obtained here by aligning the projection vector with the diagonal of the cube, right? Now there are 8 positions, one in each octant, for obtaining an isometric view. All the 3 axes, that is x axis, y axis and z axis, these are basically known as the principal axis, are foreshortened equally in an isometric projection so that the relative proportions are maintained. So this is not the case in case of general axonometric projection, where the scaling factor may be different for the 3 principal axis directions. So in this in case of isometric projection, the scaling factor is equal for the three principal axes.